Let's start at the back of the boat with the rudders. We'll begin by taking a right angle and placing it over the center of the rudder post. We'll then mark the location with a piece of tape or a marker so we get true fore and aft off the stern of the boat. We can then align the rudders centered on our mark, giving us a straight rudder. We're going to use the Ackerman steering principle on a dual rudder boat, and what that basically is in the automotive industry, the inner wheel of the circle will turn at a higher angle than the outer wheel. This is centered over the rear axle. On a boat, it's centered over the center of the keel. A boat pivots around the keel typically. To make this easy to figure out on a Volvo One Design, we'll take a string and we'll run it from the rear screw on the crossbar. We'll run it to a point about 1 inch back on the hatch, which is directly over the keel bolt in the center of the keel. We'll then want to make sure that the string lines up over the center of the rudder post. We'll do this on each side. What this will do is ensure that the rudders turn at different angles when they go from left to right and right to left. This is common on numerous boats, big, small. Most dual rudder boats have been configured this way. On this boat, we're using all Harken blocks. They have Delrin shivs with stainless steel ball bearings so we get a low friction surface. We're also using 100-pound Spectra line for no stretch on the boat and the sheets. We've shortened our sheet control arm on the boat so that we could get it straight fore and aft. What this does is, on a traditional setup, when the boat is, when there's tension, you can hear the hum from the servo. That drains battery power. However, when the arm goes full forward and we put the same tension on, there is no battery drain, there's no hum. We then run the sheet back through a block, and then we run it back forward to the main bridle, the traveler control, and then the jib actually runs through the bulkhead, and then it runs through the compression post, and then out the bow and forward up to our jib turning block. And that's how we control the sails. One other modification we did was we moved the battery tray forward in the boat. That gets weight a little bit further forward, gets the stern out of the water. Then we have the boat and the rig ready to go. The turnbuckles we added in so we could do adjustments, and then we used also Mason wire. It's about a 96-pound test stainless wire, and we just did twist ties to put that on there. And you can see we did the whole rig with that. And we could have went with Spectra, but what we decided to do here was use the wire. We don't have to worry about failure or wearing, and strength is zero stretch. On the jib, we set it up so we have a bridle coming down to a jib attachment point. We then attached both the forestay and the halyard. We ran those down through the boom, and we left all our controls at the bottom of the boom so that we can have easily repeatable settings, and we can mark the boom for our preferences. And we can just reach down and grab the boom and make adjustments. There's no need to pull on the mast, or when we take the boat apart we don't lose any adjustments. So easily repeatable settings, and one on each side. Then we mark the deck for where we want the jib to be set. So as we set the jib, we set it to the mark and tie it off, and now the jib is set for tacking. The main, we set the bridle so loose that it almost is two-blocked. That allows the main to not travel as much. We want to keep the main as close to center line as possible. You'll notice that we have a kind of a crazy string contraption going on around the boom. What this does is it allows us to actually make adjustments that we can't normally do because we aren't on the boat. So currently we have our minimum draft there on the main of about a 1/2 inch We can get it a little bit tighter if we want to flatten it out more. But as the boom eases off, you'll see that the draft increases. The geometry of the strings going around the mast allow them to go slack when the boom is eased off. And then this eases the outhaul. And then what happens is when the boom comes back in, the main will, the outhaul will tighten back up and pull it back in. So it's similar on the boat to releasing the outhaul and the Cunningham downwind. We just have it figured into the geometry. We can still adjust our base setting with the orange line here. We have that running back to the cleat, so we can still pull the outhaul down tight and set it to what we want our base setting to be for upwind performance. Same thing is true of the Cunningham. You can see the Cunningham will not go up when I pull on it. It's set at our base setting. Then as we ease the boom off, it's about a ½ inch, maybe 3/8 of an inch there above the boom. But then as we ease off the sheet, the geometry allows the sail to rise up, another ½ inch, 3/8 of an inch or so, or more. But we really don't need it to go that much, but it's allowed to. And then when it comes back, it will not move. It will be pulled back down tight. You'll notice we ran a jack line rather than put the sail in the groove. The jack line uses slugs, similar to a back car system or something like that. We run a wire down the luff of the main, and then we put little slugs into the mast. What this allows is when the sail is sheeted off downwind or on a reach especially, the sail will lay flat against the mast. And you'll see here the profile. There's a perfect shape there. What will happen, however, if the sail is traditionally put into the groove like this, you'll actually see there's an awkward curve there, a reverse foil shape that comes as the sail goes out, and that is going to give us some poor flow, a lot of turbulence, a little bit slower speed, and as we all know in yacht racing, every little bit counts. The jib set up with telltales at the top, about 10 inches down, 2 inches aft from the top and the bottom. And we've got telltales on each side that are big enough for us to read from shore, just so we can check our settings. We also have the jib as low to the boat as possible. We've removed anything that gets in the way of setting that, and then we've set it up with the outhaul traditionally. Setting up the tension on the mast and the prebend, you can see we've got about 3/8 or so prebend in the mast. Currently we just run a string from the top down to the gooseneck. When we crank on full backstay, we can actually crank that up to about 3/4 of an inch of prebend. And in the jib we have negative curve in the luff, and what we do is the same thing. We run a string from the top down to the boom, and we can pull that out with the backstay and the forestay tension, and we can control the shape of the jib that way. And then we just mark the sails at the head with the amount of cut built in by the sailmaker. And that's the boat. That's the base setup that we use on Burberry Ocean Racing with the Volvo One Design. We will follow up with a video of things to come and how we actually tune on the water before racing, and what adjustments we make based on weather. Hope to see you all again soon. Thanks. Bye.